You copy a few lines of API code from a quick tutorial, and suddenly you have a working chatbot. But the second you try to deploy that app in the real world, it breaks, and you have absolutely no idea how to debug it. To avoid that trap, we need to cut through the noise of random weekend tutorials. Today, we are mapping out a specific 4-step execution plan to take you from a beginner to a highly capable AI engineer, entirely from scratch. We are going to construct your AI knowledge base exactly the same way you build a house. We will pour a foundation, frame the walls, install the systems, and finish the interior, layer by strict layer. Before we move forward, open a blank text document on your computer or grab a pen and paper. You are going to draft your personal curriculum map and record 4 specific milestone projects right now. Writing this sequential map down is the only way to protect yourself from the shiny object trap. If you jump straight to advanced topics without passing the required milestones, your entire learning structure will collapse under its own weight. Step 1 is pouring the concrete foundation. In our case, that means mastering traditional machine learning and deep learning. For your curriculum document, write down Andrew Ng's machine learning specialization from deeplearning.ai, followed by the Introduction to Deep Learning course from MIT. Large language models are deep learning models. You must understand how they learn, which requires grasping concepts like gradient descent, backpropagation, and loss functions. Gradient descent is an optimization algorithm used to minimize errors. Backpropagation calculates how to adjust the model's weights to reduce those errors, and loss functions measure exactly how far off the model's predictions are from reality. Your first milestone project is to build and train a basic neural network classifier from scratch using Python in a Google Colab notebook. Warning tone. This chart shows a model's loss curve dropping over time and then splitting into 2 diverging lines. That divergence illustrates overfitting, which happens when a model memorizes the training data instead of learning the underlying patterns. Do not move past step 1 until you mathematically understand why this failure occurs. Without a firm grip on this mathematical foundation, the behavior of advanced AI will always feel like magic. And if a system feels like magic, systematic troubleshooting is impossible. Step 2 is erecting the wooden frame of our house. This is where we master the transformer architecture. Bookmark Jay Alamar's The Illustrated Transformer blog post and enroll in the Hugging Face NLP course. Add both to your map. The core innovation of modern models is self-attention. It allows processing models to look at surrounding words in a sequence to properly establish deep context and weight relationships. This attention mechanism is the literal engine powering models like GPT, capturing long-range dependencies in text. For your second milestone project, you will utilize the Hugging Face library to load a pre-trained transformer model and successfully run a basic inference task to generate text. Understanding how this engine processes information separates true AI engineers who can tune architectures from casual developers who merely send inputs to a third-party API. Step 3 is installing the plumbing and electrical systems. We do this by customizing the base models with private external data. Add Cohere's LLM University and deeplearning.ai's short courses on Retrieval Augmented Generation, or RAG, to your curriculum document. Many developers assume fine-tuning model weights is always the required next step, but fine-tuning is expensive and data-heavy. RAG is often a cheaper, more effective solution to give a model specialized knowledge. This flowchart shows the RAG architecture. The document retrieval box uses hybrid, dense, or sparse methods to search external vector databases. Following the path down, retrieved documents fuse with your query during prompt injection, moving into text generation to formulate an answer using private data. Your third milestone project is to build a simple RAG chatbot where you upload a PDF and successfully query the LLM for a highly specific answer contained only in that document. Providing models with external memory via RAG is the primary method the industry uses to ground outputs in factual reality and eliminate hallucinations. Step 4 is finishing and painting the house. This is where we build AI agents. Assign the Hugging Face Agents course and the UC Berkeley Large Language Model Agents course to the final section of your document. Standard chatbots only generate text. AI agents take a conceptual leap. They utilize external tools to execute actual actions in the real world with a degree of autonomy. Your final milestone project is to construct a strictly constrained research agent equipped with exactly 2 tools, a calculator and Wikipedia access. Cautionary: do not fall into the trap of agent chaos. Giving an agent open-ended autonomy too early almost always results in unpredictable, infinite failure loops. A successful, constrained output requires the agent to explicitly print its chain of thought reasoning before taking an action. Chain of thought is a prompting technique where the model breaks down its problem-solving process step by step. Mastering constrained, reliable agents is the absolute frontier of modern AI product development. Look at the document you just created. You now have a complete 4-stage map covering foundation, transformers, customization, and agents, alongside 4 verifiable milestone projects. Here is the reality check. Executing this roadmap requires 6 to 8 months of consistent, daily work. You cannot master this in a single weekend. Enduring this rigorous path is the only guarantee of becoming a highly paid, true AI engineer rather than just another prompt jockey. Go to deeplearning.ai right now and enroll in the first course, because the only difference between having an idea and being an engineer is execution.